So in that scheduled video, the video is till conflict. Okay, here. From here we can start. Conflict serializable schedule. So what is conflict? There should not be any conflict in the schedule. Okay. So here a schedule is called conflict serializability if after swapping of non-conflict operation, it can transform into a serial schedule. The schedule will be a conflict seriable if it is conflict equivalent to a serial schedule. When a schedule will be a conflict serializable if it is conflict equivalent. That everything we are going to study in this part. Okay. So conflict operation. What is that? It has some conditions. It must satisfy some conditions. That is, both belong to the same separate transactions. Both schedules belong to separate transactions. They have the same data item, but they have the same data item. Then they contain at least one write operation. They must contain at least one write operation. Okay. So here, when we see the first example, there are two schedules, S1 and S2. So here, S1 has two transactions, T1 and T2. So in the T1, what is happening? The read operation is performed first, read A. Then after completing this operation in the transaction 2, next it does the read A. So after swapping, there is no change. See, after swapping, what happens? The read operation is done again. So first the T2 read operation is done, then the T1 read operation is done. So here S1 is equal to S2. This means there is no conflict. Okay, if S1, if both the results are same, see here both the results will be same. Schedule 1 also give the same result, schedule 2 also give the same. So in this case, there is no conflict. When we take the second example, schedule 1, schedule 2, it also has T1, T2 transaction. In T1, the first read, the initial read is done. And after that, completing the initial read, transaction 2 does the write operation. When it is swapped, first the write is executed and next this transaction is done. So here, the output of these two resultant will change. So S1 becomes it not equal to S2. S1 is not equal to S2. Okay, completely it will change. So that means it is in conflict. Okay, from this two example, we know that the first example is non-conflict, second example is conflict. Okay, when the first the read operation is here, first write, read and then write, here write and then read. Totally the after swapping, S1 is not equal to S2. So we are going for conflict equivalent. What is conflict equivalent? So one can be transformed to another by swapping non-conflicting operation. Okay. One can be in the conflict equivalent, one can be transferred to another transaction by swapping non-conflict operation. Let us see the example. In this example, we are having two schedules S1 and S2. S2 is equivalent. See, S2 is equivalent to S1. Same, they are same, the operation. But when this S2 is conflict equivalent, S2, this one, to S1. See, S1, it is in the form of non-serial schedule. So we are swapping it. S1 is converted to S2 by swapping. See, the S1 is converted to S2 by swapping non-conflicting operations. So it will be transferred in this form. Okay. So what is the condition it satisfies? They contains the same data set of the transaction. In each pair of conflict operations are ordered in the same way. They are ordered in the same way. Okay. So in this manner, we can remove the conflict. Okay, conflict in a schedule. by conflict equivalent. Next one is the view serializability. What is view serializability? View schedule will view serialized if its view equivalent to serial schedule. Okay, so we must change into view equivalent then to serial schedule. So how we can change that? If a schedule is conflict serializable, then it is called as view serializable. So the view serializable, it is changed into view equivalent and then to serial schedule. So in order to do this, for view equivalent, the view serializable must be changed to view equivalent. It must satisfy, it has three conditions: initial read, then updated read, then final write. So we can study in the initial read. What is initial read? Always the transactions should start with a read operation. Okay, initial. An initial read of both schedules must be the same. Initial read, okay, that is read A, and the transaction A in schedule 1, transaction A is also reading A, transaction T1, schedule 2, transaction T1 is also reading A, the same data set. Okay, this is a first condition. See, suppose two schedule is there, S1 and S2. In schedule 1, if the transaction T1, this one, is reading the data set A, in transactions 2 also T1 must read the same data set A, should read, that is the condition. So in this table, whether this first condition is okay, it satisfies the first condition, we can see. Above table, two schedules are above two schedules are view equivalent because initial read operation in S1 is done by T1 and in S2 is also done by T1. That's what I said. So next one, updated rate. What is updated rate? So here also we are having two tables, two schedules, S1 and S2. In this schedule, when we take the T1, this here in the above schedule, the T3. Okay, okay. Here the T3A read A is updated by the write A. Okay, updated by the T2. Here, what is the condition means? If in the same table, the updation should be happen in same manner. If the T3 is reading A, reading A is updated by T2. The same thing T3, the schedule 2 also, T3A is updated only by T2. But here, what is happening? So here T3 is updated by T1, but here T3 is updated by T1 in this schedule 2. Okay, this read, okay, this write. So it does not satisfy the second condition. So this second condition, once again, I'm repeating, see here. So in T3, there is a read operation. So this T3 read is updated. T3 read A is updated by T2. The same thing here also must happen. Schedule 2 also, T3 A is updated by T2. But here what is happening? T3 reading A is updated by T1 here. So it's the update reading fails here. Okay. So next last condition is final write. A final write must be same between both the schedules. Here also same thing. The final write must be same in the both the schedule. So in for example, there are two schedules. So here also in the schedule 1, if the transaction TA updates A at last, then see here in schedule S1 in transaction T3, the write operation is in T3. Here also schedule 2, the write operation is in final write operation is in T3. So it satisfies the third condition. Okay, so third condition it satisfies. Same thing in this table, we have to check whether the three conditions are satisfied here in order to form a view equivalent. Okay, in order to bring a view equivalent, we have to see whether the three conditions are satisfied here. So first one, we can see initial two schedules are there, S1 and S2. Okay, two schedules are there. S and S1, two schedules. So here, first transaction, initial is read A, here also initial is read A. So it is satisfied. Then in second condition, what is the second condition? Updated read. Here is no read value at the updated form at the last. So it see final updation on dataset in both them. No read expected. See, no read is there. So the second condition we no need to check. So the third condition is final write. Final write, both the transaction, both the schedule, last is transaction. That is final is write A, write A. So here also it satisfies the view equivalent. So the view equivalent serial schedule is T1. The T3 depends on T2, T2 depends on T1. Likewise it is. Thank you.